Alright everybody, so today I'm going to be taking you through a sort of a truncated version of Required Practical 3, which is an investigation into sort of osmosis in potato tissue. So the principle upon this, upon which this is based, is the idea that water will travel, when it comes to sort of two differential areas separated by a semi-permeable membrane, will travel through this semi-permeable membrane from an area of higher water concentration or water potential to a lower area. So it's sort of a type of diffusion, but specific to water and with a semi-permeable membrane. So in this case, our semi-permeable membrane is going to be the tissue, or the sort of cell wall / tissue structure of potato flesh, not the skin bit, and I'll get onto that in a moment, but the tissue itself. So what we've got here, laid out before us in this lovely little demonstration, is a series of boiling tubes that have just got mounted liquid in them, a solution of varying sort of molarity of sucrose, so table sugar. So we've got 1 molar, 0.8, 0.6, 0.4, 0.2 and 0.0. And this will give a nice range of water concentration in the inverse to the sugar concentration. So, you know, if you put more sugar in something, there's less water in it, basically put. So we've got 0.0 concentration here, which is just pure distilled water. So this is effectively 100% water, very high water concentration or water potential. And then as we go up here, we've got a bit more sugar, bit more, until this is, and let me tell you, just from personal experience, this is very hard to actually dissolve at this concentration because it's almost entirely saturated. Anyway, so we've got our 6 different concentrations here, and we've got our potato. So how are we going to measure how quickly or not quickly, or how much water sort of transfer goes on, how much osmosis occurs? Nice little way of doing this is we are effectively going to core our potato here. So I've got cork borer here, so we're going to cut 6 different cores of equal or equivalent lengths and diameters, because it's the same cork borer, to keep things the same. And we're going to submerge them in our varying solutions and see how much the mass of them changes. And the theory is that if you're, let's say your potato is quite watery but not fully watery, otherwise it would just be water. That if you put a core in a solution that is entirely water, then because of the principles of osmosis, the water will move from the higher potential to the lower potential down this concentration gradient, which means that your potato core will increase in mass overall. And the reverse is true. So if you put it in a solution that is sort of much less watery or much more sugary in this example, then in theory, according to osmosis, water will exit the cells of this potato flesh and the core itself and will enter into the surrounding solution down that concentration gradient of water. So how are we going to measure that? Very simply, we're going to measure the mass before and after a 20-minute soak in each of these various sort of concentrations. And then hopefully that will correspond quite linearly to an amount of water that is either left or entered the potato core. And from that we can work out a percentage change in mass, because obviously even if we're very good about making our potato cores the same length, mass isn't always going to be identical. So we're going to sort of do up some percentages, put it into a graph, and hopefully we should be able to find a point at which, a sort of water potential at which the water concentration on the inside of the cells is identical to the surroundings, and that's what we call the isotonic point. So that's the point at which there's no overall, and again this is overall, loss or gain in mass of this core, because it's equivalent in terms of water potential and therefore sugar concentration to the surroundings. It's a very long-winded explanation. Hopefully that'll be the last I do of it for a while, so I'm just going to get on with it. So we're going to take our cork borer here, this is a number 4 standard size, and we're just going to punch through onto our chopping board. I haven't really thought about how I'm going to get them out, which is why I'm going to need to go get a bit of sticky poly stuff. Or I can use this. So move this out to the side. Come on. Almost there. Right, and hopefully hopefully that will just come out. So I'm decided to use cores of approximately 2 centimeters, just because it's a nice round number and I think it will submerge quite well in our boiling tubes. I shouldn't need too many full cores, these are quite long. Where's my pipette? Very proper use of a pipette. There we go, just to get the little end out. What's also important, some of you might be thinking this, is but wait, if we've got our core here, at one end or at both ends, you've got a bit of potato skin, this stuff. And that's definitely not going to have the same sort of semi-permeable status as the inner flesh here. So what I'm going to do is I'm going to very, as close as I can, remove each end of all the cores I make so that we just have a repeatable, fair sort of standard of core. I'll try not to make a smiley face out of this. So hopefully I should be able, that's interesting. What's happened there is I've sort of intersected one of my previous boards, that's all right. Let's cut it off there, I can just go away. Probably gonna need maybe one more, maybe two. I only need 6 cores in this case. So let's grab our cork borer, go away a bit. I'll put it down, there we go. That should be enough, I should hope. There we go. Nice noise there. Great. Right, so straight away, I'm going to use my scalpel here to remove the ends, just snip the ends off, try and cut it as perpendicularly as possible. I'm just going to leave that. No, I'm going to chuck that away. I've got a bucket off screen, don't worry. Won't be perfect, but it should be good enough for our cores. And then as perpendicular as possible. Like that. That's looking almost, I'm not sure. Oh, that's just a bit of leftover skin. I'm not sure if that little core there is exactly 2 centimeters, but I'll be surprised if it is. So we've got our longer cores, and we're going to get rid of them. Okay, so now we're going to measure up and try and get them as close to 2 centimeters and as uniformly 2 centimeters as possible. So that's well over 4 there. So let's go for there. So that's 2 centimeter core. That's 2 centimeter core. It's very close. Okay, so I've still got a bit of this accidental overlap in cores there, so that hopefully should make sure it's a nice uniform cylinder. Just about. Another 2 centimeters. So I need 3 more. Let's go. It's not a perfect perpendicular cut there, so let's another 2 centimeters. Another 2 centimeters. And do bear in mind you are viewing this from an angle, so it might not line up perfectly from your view, but I assure you I am capable of using a ruler. At least I hope so. We'll see. Going there. Okay. So that is our 6. So I'm going to remove this core here, remove our potato. Don't need them anymore. Don't need our cork borer anymore. So what's important that we do before we add it to the solutions is that we're going to blot dry each of our cores. Now the reason for that is that you don't want any sort of excess moisture that's clinging to the sort of outer surface of the potato. I mean, you just sort of slice through it with a cork borer, there's going to be some sort of some liquid and some fluid sort of diffuse out. So we're going to blot them dry just so that any excess moisture doesn't affect our results. So I'm just going to take a bit of blue roll, just roll it around a bit, and you can see there's a little bit of moisture coming off of it. You don't need to squeeze it too hard, otherwise you'll start damaging cells and affecting your results that way. So Let's make sure our balance is zeroed. And our results. So once it settles, 0.87. So this is going to go in zero concentration. Going with 7 even though it's fluctuating. So that's going to go here. We're going to do the same blotting procedure. I have to move the paper about just to get some dry bits. Just blot it dry, make sure it's zeroed. That's remarkably consistent, I'm impressed. 0.88. That's going in on 0.2. More blotting, lucky us. Blot the ends as well. That's on 0. 0.88. Oh, I'm good. Oh no, 0.89. You'll have to forgive my handwriting. 0.84. There we are. This is, sorry, 0.4, 0.84. Too many numbers. This is going to be our 0.6 core. Oof, 0.9. Oh, 0.9. I'm going 0.9. That's going in our 0.6 tube. This one was quite moist. Lovely word. Alright, let's measure it now. 0.88. It's going in our 0.81. And finally, at long last, we have our final core, which is going to go in our 1 molar solution, measures in at a whopping 0.88. Fairly consistent, I'd say. I'm impressed with myself. Right, so what I'm going to do now is I'm going to place them, straighten up a bit, in their respective boiling tubes, and I'm going to leave for 20 minutes. Now I'm not going to make you watch for 20 minutes, so I might cut to another shot in a second, but I'll be leaving this stopwatch running. I mean, there will be a few seconds difference between each thing, but it won't make much difference, I promise you. And we will see what the results are. So, start with that one, that one, that one, that one, and that one, and that one. Okay. I'm going to leave that running, and I'll be back quite shortly. Well, for you, actually quite shortly. For me, it's 20 minutes. And we'll see what our results are. Okay, we're coming to the end of our time. 1955. Right. Okay, 20 minutes. I'm just going to pour away the solutions while retaining the cores. Right, so those two. So we've got 0 on the right. Come on. 0.2 there. So we're just going to blot them dry again to make sure there's no excess moisture. So for 0 concentration of sugar, which would mean 100% water, 0.91. And for 0.2 molar sucrose, which would slightly less water. Come on. Not 0.8. Oops, I've done that wrong, haven't I? 0.91, 0.88. Right, let's get 0.4 and 0.6. So 0.4 on the right there, 0.6 on the left. let's do 0.4 next. Right, 0.4, 0.88, 0.6 molarity. Come on, go back to 0. 0.86, if I get my pen. We can see that trend is starting to reverse now. We've got our final 2 cores. Just going to get some fresh tissue. It's all a bit sodden. Get rid of all that. Fresh blue roll. Right, our 2 cores. And so on the right we've got 0.8. On the left we've got 1.0. So we'll just block those dry as well. Oops. Shouldn't mix those 2 up. Okay, so I'm calling that more or less dry. So let's go 0.8 to continue the trend. 0.83. Oh, sorry, 8.5. That. Yeah, I'll go with 8.5. That's fair. 8.5 is what it measured. 0.85. And then finally, for our highest concentration sugar solution, 0.81. Right, so I'll tabulate those results and produce a little graph, and hopefully you'll be shown that graph in a moment. But as we can already see, just from our sort of raw data here, with your concentration of sugar at nothing, so it's pure water, we do have the mass of the potato core increasing, because with pure water it's going across that membrane into a less water concentrated area. And at the highest concentration of sugar, which would be the lowest concentration of water, we do have a mass change of a negative nature, meaning that water has left the core and entered the environment. So we've already seen there's a sort of fairly obvious trend just from looking at the raw data, but I will tabulate it all up and put it into a graphical format. Hopefully that'll be displayed to you now. All right, I think that's us done.